Okay, everything is fine. So this is supposed to be our replacement. 30 minutes, maybe minus 5 minutes. I'm lazy, you know. But with all seriousness, we want to revise from 4 chapter 3. If you look at the last few pages of your August book, you will see, I think there are like 7 pages of from 4 chapter 3, because every single year before SPM, this is the first thing that I will revise after we finish the syllabus. So before that begins, right, remember that the questions, whether it's paper 1 or paper 2 or whatever, it always starts the same way. Okay, let's see. Right, so here's the page 14 of the book. So the questions may come and go here and there. Some of them don't actually have much to do with calculations. For example, if you look at question number 26, this is the apparatus set up to determine the empirical formula of copper to oxide. As you can see, they don't ask you to calculate anything. So in this case, you can just answer logically. But then you go to question number 27. All right, table 2 shows the proton and nucleon number, blah, blah, blah. Find the molar mass. Right. And then the next one, number 28, they are also, again, has really nothing much to do with mathematics. So it's kind of like, you know, a mixture of both. I'm going to focus more on the calculation part. Now, in that case, all right, first thing you will need to do is to write down the equation if they didn't give it to you. So sometimes they give it to you already, so that's fine. If they don't, however, you have to write it down yourself. And then always, the next thing you do is find the mole. So make sure you know that when it comes to the solids, right, solid materials, like in Form 4 Chapter 3, we haven't taught you yet about MB per centimeter. So here, they will just give you, for example, right, maybe we will give you the mass, and maybe we will give you the volume if it's a gas. Right. Either way, from there, you're supposed to be able to find what is the number of mole of whatever you're reacting. For example, when they give you the mass of sodium, then from there you can find the mole by dividing the molar mass. And this will be given to you, no problem, in the form of the relative atomic mass. Now here on the hand, you have to divide the molar volume. And this is even easier because the molar volume is usually fixed. They will give you the value, whether it's 22.4 decimeter cube per mole or 24 decimeter cube per mole. And the rarest at this point will be the number of particles, number of atoms or molecules or whatever. Now, they rarely do this because it's very impractical, but if they do, then all you need to do is to play around with the Avogadro's constant. So in this case, you will divide it by 6 times 10 to the power of 23 per mole. Having said that, right, this value may change to 6.02. All right, it depends on what constant they give you. But just like molar volume, right, it is already fixed. They will either give you 22.4 or 24. All right. So let's try to, with this knowledge, let's try to answer as much questions as we can. But this question, number 14 here, has nothing to do with any of that. So you see here, table 2 shows the proton number and the nuclear number of atoms of elements X and Y. X and Y are not the actual symbols of the elements. Okay. So given that X is here and Y is here, you got the proton number 13. So from here, you know the electron arrangement of X is 2H3. It's X. Y has 8 protons. That's 2, 6. Okay, from here, even if let's say you have practiced it, you don't even look at the nuclear number, you don't look at the periodic table, you know 283 is aluminium. You know that 26 is oxygen. And therefore, when they react with each other, you will get aluminium or Al2O3. You can replace that with X2Y3. All right. And then now they want you to find the molar mass of the compound. So the molar mass is equal to the mass of X plus the mass of Y. All right, Y you have 3. So 16 times 3 is 48. And X you have 2. So times 2 here, you get 54. So 54 plus 48 will be equal to 102 grams per mole. So it's not hard, I think. It's quite easy. And this doesn't really require your the first thing that I drew just now, you know, all the connection between the mole and mass and all that. But the next question probably will. We'll go to the next page. Right? My aim here is to answer one question from each page. And here, okay, so we've got some more mathematical questions. This one doesn't really have anything to do with that. All you need to do is to this one involves simple algebra. So I'll leave this to you. Fine. Yeah, question number 32. The following equation represents the reaction between sodium and oxygen. 4Na plus O2 equals to 2Na2O. Very nice of them to give you this equation. What is the maximum mass of sodium oxide formed when 11.5 grams of sodium is hit completely in oxygen? Okay, so nice that they give this to you. So we are going to take advantage of this information. First things first, 11.5 gram of sodium. You have to change this to mole. As I already say in step number 2, step number 1 is write the equation. They've done that for you. So step number 2, find the mole. Since they say they reacted completely with oxygen, well, what it means is that you have enough oxygen. Oxygen is in excess. The limiting factor here is the sodium. So sodium will run out first, which will affect the amount of sodium oxide you get. So the number of moles is mass divided by molar mass. So that will be, what do you call it? Don't worry about this 4. This 4 and this 2 and whatever this number is here is just to show you the ratio of the product compared to the reactant. Right? When it comes to calculating the mole, it is not involved. So let's just say 11.5 grams given, and you divide it by 23 grams per mole. So you get 0.5 mole. Right? So you have 0.5 mole of sodium over here. How many moles of sodium oxide are you going to make? Right? So since 4 produces 2, you just divide by 2. So 0.5 divided by 2, you end up producing 0.25 moles of sodium oxide. Now we have to find the mass though. And they write maximum mass because sometimes you won't get exactly the amount because there will be some, maybe the sodium doesn't actually heat completely. Right? No matter how well you set up the experiment, things don't go perfectly sometimes. But anyway, the maximum mass you could get will be 0.25 mole multiplied by the molar mass. So the molar mass of sodium oxide, Na2O, would be given here. Sodium is 23. So 23 times 2 is 46. And oxygen, there's only 1 here. So just add with 16. And you get 62 grams per mole. Okay? So we're going to multiply that. Again, you don't have to worry about these 2 over here. They are only here for the ratio when it comes to the equation. But when it comes to calculating the mass, they are not involved. So 0.25 times 62 is basically 62 divided by 4, a quarter. That will be equal to 15.5. I'm not using calculator, so it's correct. So the answer should be 15.5 grams. Okay, quite easy. How many minutes have we gone? Because I'm planning to talk about like 4 questions, but 8 minutes. Not too bad. You guys wouldn't mind if this ends in like 20 minutes, right? Alright, anyway, so the next page. Question 35 up to 38. Oh, quite a few calculation questions here. So 35 you can settle yourself. 36 is calculation. 37 as well. And then you have 39. So out of the 3 questions, we're going to pick one. And I'm going for 37. The reason is because I saw the word photosynthesis there. So the following chemical equation represents photosynthesis process. And they give you the chemical equation again. So remember that they are sometimes not as nice to you guys. As you can see over here on page 39, what is the mass of sodium chloride obtained when 50 centimeter cube of sodium hydroxide react with 50 centimeter cube? You can see that they didn't give you the equation. You have to write that down. So write down the equation and then you calculate how many moles you have. But because this one involves a solution, you must use MV per centibu lah. Never mind that. Like I said, I promise number 37, we're going to go for that. Okay, so this carbon dioxide reacting with water in the present, and you will have glucose, oxygen, as well as water again. You probably wonder, teacher, there's 12 water here and then there's 6 over here. Why don't they just cancel each other out? Now, if you study bio, you know why. If you didn't study bio, just accept it for what it is. It's a bit, complicated to explain. But think about it this way. All right, they say here, what is the mass of glucose produced if 1.2 decimeter cube of carbon dioxide gas is used. So what this means is that the water here is going to be excess. They don't have to mention it. Okay, even in real life, plants usually, if they cannot perform photosynthesis, is because of the lack of carbon dioxide. The carbon dioxide is the limiting factor. Water usually is not. Because if there is a lack of water, the plant will die anyway. So you don't have to worry about photosynthesis because you're dead. So what is the mass of glucose produced if 1.2 decimeter cube of carbon dioxide gas is used? So we look at here, 1.2 decimeter cube. We're going to change this to the mole. All right. And I've already given this to you. The volume. All right. You want to change it to the mole, you have to divide by the molar volume. It's either 22.4 or 24. And I haven't actually seen the rest of this question. All right. But just looking at 1.2, I think they are going to give us 24 decimeter cube per molar. There you go. Right, so the molar volume of gas at room condition is 24 decimeter cube per mole. You want to make it easy visible. So so you have to take 1.2 decimeter cube, divide by 24 decimeter cube per mole, and you get 0.05 mole. So you have 0.05 mole of carbon dioxide. How many moles of glucose are you going to make? I know you want to look for the mass, but you must change to mole, and then only you can change to mass. So this further, right, you have to take 0.05 mole and divide by 6 because 6 produces 1. Therefore, whatever I have over here must be divided by 6. So unfortunately, right, 0.05 divided by 6 is a very, not just the fact that it's a very small number, it's not perfectly divisible. So let me just 0.00833. 0.00833 mole. This is the mole of glucose you will produce. It may seem like it's very little, but that's because we haven't seen the molar mass of glucose yet. Let's see, glucose is C6H12O6. We have to calculate that. And the question, like I said, is already going to supply that to you. So carbon is 12, oxygen is 16, hydrogen is 1. So C6H12O6. The molar mass would be equal, or you find the relative molecular mass first. That will be 6 times 12 plus 12. Right, don't have to multiply by 1 now. Plus, 6 oxygen will be 6 times 16. So what's the total? 72 plus 12 is 84. 84 plus 96, right? Bro, we need a calculator here, sorry. So 72 plus 12 is 84. Then you got 16 times 6. So yeah, 180. Alright, so that's the mass. 180 gram per mole of glucose. So guys, the next time, whenever you like buy sugar, like pure glucose lah, then you buy 180 grams worth of it, right? That is equal to 1 mole of glucose. Quite a large number lah. So from there, we're gonna multiply 0.0083 times with this. Let me use my calculator. I got 1.499. 1.499, which is, the closest number is 1.5 grams. So okay now. Even if you have an issue, right, you can always like rewind and watch it again. So you wouldn't need my recap, huh? John and anyone else who is obsessed with recapping. So we go to the last page. And if I'm not wrong, the last page doesn't have that many questions anyway. Especially the ones involving. Oh, but here we go. We have question number 43. I think this is good. Let's just make more space. This further is going to require a lot of writing down. So question 43 should be the last one. The following chemical equation shows the decomposition led to nitrate. And the given equation. See, they've already given you the equation. So far, we have never had to write any of our own yet. So that's good. What is the mass of lead to nitrate needed to produce 3.6 decimeter cube of oxygen gas at room conditions? Right, given that they already told you 24 decimeter cube per mole. Okay, nice. Okay, so first thing you do is find the mole. Find the mole. What is the mass of lead to nitrate? So this is the answer you want. Sorry. Oh, lead 2 nitrate. That means they want you to find the mass of this. They will produce 3.6 decimeter cube of oxygen gas. Okay, no problem. Okay. We're gonna find the number of mole of oxygen that we need to make. Okay, given that 24 decimeter cube. So we just take 3.6 decimeter cube, divide by that to find the number of mole of oxygen. So let me just calculate that. 0.15. Okay, what do I do next? Now I know that I have 0.15 mole over here. How many mole of lead nitrate do I need? Quite easy, right? If 2 produces 1, how many produces 1.5? Right? This is 1, this is 2. So the ratio is 2 of these produces 1 of this. Therefore, I would need double of 0.15 mole. That will be 0.3 mole. So I will need in total 0.3 mole of lead 2 nitrate. The problem is I need to multiply this by the molar mass and we don't know what it is yet. So let's say PbNO32. Again, don't worry about this 2. It's just for ratio. Now we just want to calculate this thing right here. So lead is 207. Then you're gonna add this with, okay, what I'm gonna do is I put 2 over here. And then calculate that. You've got 14 plus, wow, this is a lot of brackets, isn't it? Never mind. So this is 14, and we got oxygen. Oxygen is 3 times 16. 3 times 16. So that will be 48. This is the relative molecular mass. So you got this one will be equal to 62. 62 times 2 is 124, right? 124 plus 207. Let me use my calculator. 124 plus 207, 331. So this is the molar mass of lead 2 nitrate. I only need 0.3 mole though. Right. So again, we'll do this, and I've got 99.3. That's how much I would need to produce 3.6 decimeter cube of oxygen. Let's see if there's any of the, yes, it's right here. B, 99.3 grams. Okay, so I don't know what time it is. How long is it already? Oh, it's only 18 minutes. I think I've done discussing what I need to from at least paper 1, right? But perhaps I can give you guys like a few minutes in paper 2. So you guys have no issue lah, I hope. So some of the other questions here are not as difficult. Turns out this question is not actually that challenging. Yes, it doesn't actually involve lead oxide or nitrogen, what do you call it? Nitrogen dioxide or whatever. So let's get a paper 2 lah. All right. It's SPM 2018 question number 3. So it's very nice of them to try to even explain this to you. The mass of an atom is very small. Therefore, a chemist determines the mass of an atom by comparing the mass of the atom with another atom, which is called relative atomic mass. Diagram 3 shows the comparisons of mass between atom X with atom carbon 12. Okay, so I'll zoom out here and remind you guys that this is the, what page is this? I think it's page 18 or 19 or something in your August book. And you have to answer this. I mean, this is one of the first few things that you've learned in chapter 3. Alright. And one of the first things that really confuse you, I think, in the world of chemistry. What's the meaning of relative atomic mass? You should already know this. And the keyword here is 1 over 12 carbon 12, right? This is like I don't know if this is a clue or just outright the answer. So I just write down like the clues over here. Now, give one reason why carbon 12 is used as a standard atom to compare the mass of atom. So what do you guys think? I mean, based on your knowledge, like what carbon? So there are quite a few factors Some of them would include the fact that it has something to do with reactivity. All right, and the other one is easily available. Okay, that's already way too many clues. Now, based on diagram 3, state the relative atomic mass of for atom X. You should have no problem lah. You have 2 atom X equal to 1. No, 1 atom X is equal to 2 carbon 12. So you know what the number is. And from that point on, suddenly it changes. X reacts with chlorine to produce the compound XCl2. Write a chemical equation for the reaction. So at this point, guys, it's up to you lah. You should be able to understand this. And then interpret the chemical equation in quantitative terms. Now, you probably wonder, what are they trying to say here? So never mind, you write the equation. For example, let's say I write this lah, H2SO4 react with zinc to form zinc sulfate. And no, this is not a good example. Let's go for sodium hydroxide. So you balance the equation, you will Na2SO4 and water. So assuming, right, this is the equation that they want you to write, and it's not now obviously they already say this chlorine and then CCl2 and what XCl2 and whatever. So if they ever ask you to interpret the chemical equation, interpret this in quantitative terms, all you need to do is say 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide to form 1 mole of sodium sulfate and 2 moles of water. So you just have to write them down, just interpret it, just elaborate from there. And finally, the relative atomic mass of X, calculate the number of moles of chlorine needed. Should I help you guys with this? But that would mean spoiling the answers. Well, you know what? Let's look at the next page. That's page 18. So we can go to page 19 here. Yeah, you guys still remember about this empirical formula thingy, right? Complete the table below to determine the empirical formula of oxide of X. Given that the relative atomic mass of oxygen is 16. Okay, so X, like this this is a completely new question, right? They are still using X, but there's nothing to do with the chlorine one. The chlorine one, I want you guys to answer yourself. This one, we have X 1.92 and the RAM of, the RAM of X is 24, right? Because it's equal to 2 carbon 12 atoms. So it's 24 times heavier than 1/12 of a carbon 12 atom. So the RAM is 24. And the number of mole therefore is 1.92 divided by 24. Here it will be 1.28 divided by 16. So calculation time. 1.92 divided by 24. I've got 0.08 here. It should be the same, but let's see. 1.28 divided by 16, 0.08. Oops, yes. What I'm supposed to write is this ratio. So on both sides, I will 0.08. So I'm going to divide it by itself. And you get 1 on both sides. Therefore, the empirical formula will be XO. XO. Okay, so I don't know, is it 30 minutes? Probably less, but I think I've given you enough. It's around 25 minutes. So I want you guys to, I don't know whether you want to read this or not, just make sure you finish the last 7 pages of the August book, because we want to discuss it in our next class. So the next class, what I'm going to do is I'm going to give you guys the first 10 minutes, right? You will try to finish up this exercise if you haven't. And if you already did, but there are some questions you're not sure, you ask me during the class itself. All right, and then we will finish up the August book finally, proceed with September, do some of the exercises from the last chapter, and then it's revision time. All right, especially if you look at the September book. Okay, if you have no problem, then that will be it. I'll stop recording now. Bye-bye.